What's that boat? It's for the Robot X competition, an unmanned water and air vehicle competition that we've been helping out for. But first, who are we?
Hi, I'm Kenzo.
Hi, I'm Ali.
Hi, I'm Dina.
Hi, I'm Akshara.
And this is the Robot X Perception Navigation Team.
All hands, hoist the colors high.
Robot X consists of a series of challenges to mimic real-life applications from coastal surveillance to port security to oceanographic operations. This is the boat that will compete, but as of the beginning of this quarter, the software drivers weren't written yet, so we worked and tested on this boat, which has essentially the same types of sensors and thruster control. Our goal for the quarter was to implement the follow the path task, which consists of autonomously navigating the boat through red and green buoys. There's two parts to achieving this task: perception, identifying the buoys through the camera stream, and navigation, creating steering commands for the thrusters to guide the boat through the path. Together, we can achieve autonomous navigation.
Let's start with what we did in perception. In order to navigate the roboboat autonomously, the boat must be able to perceive obstacles and identify buoys as well as a path created by them. To do this, we first need to set up our system, set up scripts in order to be able to establish access to the roboboat Jetson, and then set up ROS nodes in order to access the OAK-D camera via the Jetson. Additionally, we had access to GPS and LiDAR information, which we decided to integrate as possible stretch goals. Initially, we gathered around 300 images of the buoys and annotated them using RoboFlow and trained a YOLO v5 model on these images. We then iterated on this and trained a YOLO v8 model on around 37,000 augmented images collected from multiple Robot X competitions. Here is the YOLO v5 model in action. Next is navigation. Based on the detective buoy bounding boxes, we built a path prediction algorithm. The algorithm utilizes a polygon created from the sorted buoy positions and memory of their location, calculates the midpoint of the path relative to the horizontal center of the frame, and issues steering commands based on threshold sensitivities for left and right movements. Here is path detection in action. As you can see, the steering commands update in order to keep the midpoint of the path in the center of the frame. When the red buoys are out of frame, we steer right, and when the green buoys are out of frame, we steer left, and when we are in the center, we're able to move forward. We also wrote two ROS nodes, the navigation ROS node, which subscribes to the perception node and publishes high-level steering directions, and the serial server node, which subscribes to the auto navigation node as a middleman to the low-level code running on the Jetson. Altogether, this is what our pipeline looked like. The YOLO v8 model ran on the OAK-D camera to output detections to the perception node. The perception node outputted these detections to the navigation node to perform path detection and determine a steering direction. These high-level commands are outputted to the serial server node, which communicates with the script running on the Jetson to translate these commands into low-level thruster movements and successfully navigate the boat. And this brings us to our demo. Here is the roboboat running our scripts to adjust for the curve in the buoys and successfully navigate through the path. Here is the view from the roboboat and how the buoy and path detection looked like from its camera. And this brings us to our conclusion. We ran into several hardware and software blockers over the course of this project. We were able to adjust our plan and meet our MVP, as well as iterate and improve upon both our detection and navigation logic. Next steps for this project include some of the stretch goals that we mentioned earlier, to both improve path detection utilizing GPS and LiDAR information, as well as perform sensor fusion for a more robust navigation algorithm. And that concludes our project. Thank you so much for your time, and wish us luck in the upcoming Robot X competition.